Hello, 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 and welcome to Renee's super fabulous show about the thalamus. And I'm your host, Renee Leal. Today, we're going to identify parts of the thalamus. But to do that, first we gotta find the thing, huh? And to do that, we pull out the whole brain I modeled last week. Right here. It's kinda angry, huh? Usually, to identify the thalamus, all you gotta do is do a sagittal cut right down the middle fissure. Like so. Easy enough. To find the thalamus, you just go to where the big bulge is here. This is called a pons. You go above it one level to an area, and this is the midbrain right here. And then right above it, you'll see this kind of big oval shaped thing, if you zoom in, and then a smaller circle in the middle. The bigger oval here is the thalamus. If we get rid of the rest of the brain, like so, you get left with this view. This is the anterior part, or the part that's closer to your eyeballs, while this latter part over here with the bumps on the back, that's more posterior, closer to the back of your head. Now this is a sick view and all, but you gotta rotate it a little bit to be able to label all the nuclei parts. So we're just gonna do a quick little flip around. When you flip it around, you get this kind of brainish looking shape with two lobes. You should know that they're mirror images of each other, with both doing the same tasks. Both lobes are connected by this little middle part called the massa intermedia. Let's start labeling anterior, which would be up here, to posterior. Now first, the reticular nuclei sheaths around the thalamus. Next, you got the anterior nuclei. And that efferents information to the cingulate cortex, which is in charge of behavioral and emotional responses and regulation. Posterior to that, you have this kind of Y formation here, which in practice can be used to separate medial and dorsal aspects of the thalamus lobes. This kind of separation border is called the internal medullary lamina. Inside of this border area is also intralaminar nuclei. Moving on to below the anterior nuclei is the ventral anterior nuclei, which efferents information to the premotor cortex. That took forever. Which helps efferent information to the premotor cortex, which is where you decide how you're going to do a motion. Like how I'm holding this microphone. I could hold it like this, could hold it like this, I don't know, but the premotor cortex helps decide that. Moving on to more motor stuff, if you go below that and really lateral, you get to the ventral lateral nuclei, which efferents information to the primary motor cortex, which is how you activate your muscles to go do stuff. Then a little bit more medial, but still lateral to the lamina, is the lateral dorsal nuclei. Going just posterior to that nuclei is the lateral posterior nuclei. And then if we go a little bit more lateral, on the same area, you get to the ventral posterior nuclei, which is in charge of helping you feel, because it efferents information to the somatosensory cortex, which is how you can feel whatever you're feeling. And then when you go to the most posterior part of the thalamus, without getting to these weird bumps at the bottom, you get the pulvinar nuclei region. The pulvinar region assists in helping move information data to the relevant places, like in your temporal, parietal, and occipital lobes. And then the thing that's super medial, but not the intermedia massa, remember that, is the medial dorsal nuclei. The medial dorsal nuclei help in regulating the limbic system by moving information to your prefrontal cortex. It's part of a greater feedback loop, which we could go into, but this is a 5-minute video, so never mind. Moving on to the fun stuff, we're at the bumps. There's 2 bumps on each lobe that are mirrored just like the rest of the nuclei. The most medial of these bumps is called the medial geniculate, and it's in charge of helping efferent information to your auditory cortex so you can listen to my scratchy voice. Should probably get rid of that part. And then lastly, you have the lateral geniculate, which helps move optic information to its relevant visual cortex. Fellas, guess what? Q&A! So how do I make these 3D models that spin, huh? So I use an iPad app called Nomad, and then after I was done sculpting, I imported them into Procreate, and I just did some coloring in the labeling to make it easier for us to distinguish different parts of the brain. So Nomad for sculpt, Procreate for coloring. What incredible resources did I use for this project? I used Professor Taylor's amazing slides from UTD. Anyway, thanks for listening to the video, and I hope you learned something about the thalamus.